Now we're just going to talk a bit about some definitions that we need to know in geometry. And these ones are going to be about theorems. So a few definitions. First of all, we need the definition of what a theorem is. You need to know these definitions as if it's science. They can just be asked, what is a theorem? Give an example of a theorem. So the what is a theorem? You'd write down this. A theorem is a mathematical statement that can be proved using logical steps. So a series of logical steps. Now, good news for the Leaving Cert, you don't have to prove any theorems for ordinary level. However, you need to know the statement and how to use several theorems. All of your junior cert theorems, you have to be able to use them, like Pythagoras theorem, which we have been using. And there are 3 new theorems that weren't on the junior cert that you have to know the statements of and know how to use them. You also need to know this definition, which wasn't on for junior cert, and it's converse. So converse, not the shoes, means reverse or opposite. It even sounds like reverse. Reverse or opposite. We'll give an example in a while. So the converse of a theorem is the statement reversed. So usually a theorem will be something like, if you have a right-angled triangle, then the square of the hypotenuse is equal to the sum of the other 2 sides. The converse reverses the if and the then. So let's remind ourselves of this. We reverse, or we swap the if and then statements. We have an example. Pythagoras theorem states that if you have a right-angled triangle, then the hypotenuse squared is equal to the sum of the squares of the other 2 sides. The converse of Pythagoras theorem, I sometimes say conversely, the converse of Pythagoras is going to swap the if and then statements. It says that if the square and the hypotenuse is equal to the sum of the other 2 sides, if the hypotenuse squared, or the longest side squared, is equal to the other 2 sides squared and added together, other 2 sides, then you have a right-angled triangle. Now, that might seem obvious, and with something like Pythagoras theorem, it is obvious, but this is a really important point. The converse of a theorem is not always true. So just because something is true in one direction, it doesn't mean that it's true in the opposite direction. The converse of a theorem, or a statement in maths at all, is not always true. Let's look at an example. It's not exactly going to be a theorem, but it's going to be a statement. I want to pick one that's nice and simple. So for example, if a shape is a square, then it is also a rectangle. So think about that. Is that a true statement? I'm going to tell you, yes, it is. Every square is also a rectangle, because the definition of a rectangle is that opposite sides are equal and it has 90-degree angles. Okay, so this is a true fact. Conversely, if I tried to write down the converse of that, I swap the if and the then, right? That's how I do converses. If a shape is a rectangle, then it is a square. Now, is that true? Hopefully you can see that it is not true, because the definition of a square is not just that the opposite sides are equal, but that they're all equal, all four sides are equal. So this is false, lies. Okay, right. So let's look at some important theorems that we have about triangles. We're going to start to look at triangle theorems. And the first one we want to look at is a theorem about angles and sides. You don't need to know a number, but you need to know the statement of this theorem and how we might use it in questions as well. So the statement of this theorem is that the angle make sure that's on the screen, the angle opposite the greater of two sides is bigger than the angle opposite the lesser of the two sides. Now that's a rather ugly statement and I don't like it. I prefer what we already said about scaling triangles. The longest side is opposite the biggest angle. It's across from it. And the shortest side is opposite, it's across from the smallest angle, and the one in the middle, the middle side, middle length side, is opposite the middle angle. And that's fairly obvious if we think of what a triangle might look like. Let's do a kind of a short side, medium side, and a long side. So here's my biggest angle, and it is across from the longest side. Here's my smallest angle, pointiest angle, and it's across from the shortest side. And here's the one that's in between, and it's across from the side that's in between. The converse of this theorem holds. So So we need to know the statement of that theorem and its converse. And the converse, so you do have to learn it off in the ugly language, but this is useful because this is the meaning. So the converse says that the side opposite the biggest angle, the greatest angle, in a triangle is longer than the side opposite the smaller angle, or lesser. Now, so we do need to learn those definitions exactly as they stated there. And we need to know how to use it, know what it means as well. And we'll just finish up with this fact about triangles, and it's called the triangle inequality. Sorry, off the screen there. The triangle inequality says that when you add up any of the two sides, it will always be bigger than the third side. I'll write that in English first. If you add up any of the two sides, if you add any two sides of a triangle, it will always be more than the remaining side. So let's look at what that looks like. Whatever shape the triangle is, it doesn't matter. This will always be true. So let's call this triangle A, B, C. I'm going to label our sides A, B, and C. Little a, little a, little b, little c. We always label the side across from the vertex with the same letter. We always go across rather than picking a side for it to be on. So what I can say here is, by the triangle inequality, I can write down three facts. The first is that if I add A and B together, it will be bigger than C, whatever the lengths are. If I add B and C together, it will be bigger than A. And if I add A and C together, that will be bigger than B. Okay, and that's the triangle inequality. You need to know that as a fact as well. Right, we'll do some examples with this information tomorrow. Actually, not tomorrow. Tomorrow we have a test on probability. So I will be assigning homework, but you can do it on Tuesday if you prefer. If you want to get it done and out of the way today, that's fine as well. And we'll go through the corrections of the homework on Thursday, and we'll do some examples. And remember, we're on first class tomorrow morning, so we'll have roll call as well. I'll put a reminder in Google Classroom in the morning as well. Okay, thank you very much, and let me know if you have any questions.